Hello, this is One Person Studio here, and welcome to my coding game series where I solve problem-solving challenges on easy difficulty. Today, the puzzle that I'm going to solve is called Robo Show. In this video, there's going to be two parts. The first part is me reading the goal so I can understand what to do, and the second part of this video is me actually solving the puzzle. So let's find out what I need to do. There are two rooms that are connected by service ducts, allowing floor sweeping bots to move between the rooms. The duct is very narrow, just wide enough for one bot to pass through. The bots do not have visual, laser, radar, or anything to detect obstacles. The only sensory is touching. If they meet in a duct, they will bump into each other. Collisions will cause each of them to turn around to continue moving in the opposition direction. Bob finds that it is very interesting to watch the bots bumping and bouncing back and forth. He prepared a longer transparent duct and put more bots into it, wishing to watch a sequence of bumping and bouncing bot show. He designed some starting location for the bots and then turned them all on at the same time. So this is all the assumptions that the bots need to do to find out this. What is the longest possible time for the bots to run around in the duct until all bots exist? So this is an example of two bots that move face to face for the length 10 meters. So after the initial state, it bumps at 4. After 4 seconds, the left bot is exiting, and after 2 seconds, the right bot is exiting, and the total bot running time is 8 seconds. I'm not going to use Python, I'm going to use Java, and let's find out what codingame has provided me to do. So for the first line, it's basically the length of the service duct in meters. The second line means the number of bots. For the for loop, is basically indicating the initial location of the bots measured in meters from one end of the duct. Numbers are not arranged in special order. For the output, it's basically an integer, the maximum number of seconds for the bots to continue running in the duct before they all exit. If the answer is not an integer, round it to become the nearest integer. So for the constraint, it is basically 2 less than equal to length is less than equal to 1000, and for the number of bots is 1 less than equal to n, which is less than equal to 100. There are 6 test cases. For example, simple, more bots, ping pong, traffic jam, and singular. So now the second part of this video begins.